Hello everyone, this is Aryan and today we are going to understand how we can implement Rodrigues rotation formula in C++. Now this formula is going to be the way so that we can understand how we can revolve 3D objects in a 3D space, right? So let's look into this formula and then we'll start from the base. I'm going to use Raylib library for this graphical to understand it, alright? So let's look into this formula first. So this is our Rodrigues rotation formula. So what it does is, suppose we have any initial vector r. If you want to rotate it by any angle theta about any axis, then next vector is r dash. So this formula gives us this r dash. This formula is very easy. It's a vectorial form. Basically, it replaces that matrix form with the simple vectorial form where we know all these. The next vector will be this whole formula. Theta will be the angle by which you want to revolve. We are going to make a project where we'll see a 3D sphere rotating about any axis. We can adjust its acceleration, speed, everything in the project, and we will understand how we can implement this formula in C++, right? So let's just begin with our project, right? Let's just quickly include all our libraries which are required here. First of all, we'll use the Ravelry library, of course, and then we'll start with uh, you know IOStream, so that in case we need anywhere we need to implement those math functions, we can easily implement those. Then of course using namespace. Sorry for this. Right. Now, before we begin, we need to we are going to go with object-oriented programming as always. So I'm going to make a class planet so that how our spheres are going to act, right? So let's make a class planet. Mm, Class planet. So in the public part, for all values are going to be available that can are going to be accessible are simple. Its center, which its radius, and right, these are things which are going to go for we need for a sphere, but since it's a sphere, so of course we also need a z-axis. So three values, a radius, and that's it. Before we go anywhere, we need to assign a vector, the vector which is going to start from the center, and a vector, and that vector is nothing but the center vector. So we are going to take a 3D vector called the center, and this is going to return us the value comma y comma z. Right, we did this thing and we created a vector here which is going to represent our center. Now let's just write some basic functions like the draw and update function. So void draw, no, wait, I think we need to remove this thing. So I think we will not consider, we will not update it directly here from center. We'll just consider this, and in the draw, I'm going to use the draw sphere function of our library, right? Inside the draw sphere function, vector. So I'm just directly going to start with center, then radius, and then color. Let's suppose we are going to take gray color here, right? In the update function, we need to assign our values, like we need to create an update function so that every time it is called, we can directly call this function and our center will have this updated values as x comma y comma z, as the x and y and z are going to get varied further in the program. So we should use this way so that we can keep this thing updated. We are going to run this inside a loop so that it is not static, it will become dynamic by this manner. So we created this class planet here. That's all we need for space. Now, let's look back into our formula and see what mathematical things we will require. So we will require cos function since we are using stream, so it has already predefined some math functions like cos and sine. So we don't need to define it ourselves. But these things are need to be defined separately. Like the cross and dot products are not available for the vectors here, and also we need to normalize our k because initially we'll assign it normally we're not going to assign it a unit vector, so we need to make another function which is going to normalize a vector. So let's begin making these functions, then we'll jump into the intermain. So let's start with a very simple dot product float dot. What it's going to take are very simple. It's going to take two vectors. So vector inside this we are going to take a vector v1 comma vector 3 v2, right? And in the output it's going to return us a value. We're going to, since it's going to return us a value which is going to be a float type only. So what it's going to return is very simple. So v1 dot x multiplied by v1, that is the x component of v1 will be multiplied with x component of v2, and then we'll add of each component, right? v2 dot x plus v1 dot y multiplied by v2 dot y, and v1 dot z multiplied by v2 dot z. This way we are going to return this value is going to be a float type only, so there is no problem because vector dot products of two vectors is going to give us the scalar as an output. Now comes to another part. We need to create a cross product function. Now cross returns as a vector only, so we need to start with making a vector function only. So let's just declare this function as a vector type of the 3D. Vector 3 cross is going to take again two vectors, vector 3 vector v1 comma vector v2, and it's going to return us the vector type. All right, so we need to understand how we are going to give us, you know, how we are going to return these vector values. For this we need to understand sorry for this what a cross product give us. So if we go to internet and look into how what cross product is, so easily we can get, so we can easily get the cross product formula from here. Like you are going to get this formula, so we will get this in this way we can write. So since I have already written this formula in a very easy way, I'll share the picture, or you can say documents in the in downward so you can see that. But let's just quickly write how what it's going to return. So it's going to return e dot y star b dot, I'm sorry for this since we are taking v1 dot y star v v2 dot z minus v2 dot y multiplied by v1 dot z, right? And the next component will be v1 dot z multiplied by v2 dot x minus v1 dot x multiplied by v2 dot z, and then we call v1 dot x multiplied by v2 dot y minus v2 dot x multiplied by v1 dot y. So this way it's going to return us the value of the cross product of these two vectors v1 v2. So we created this function for the cross product. Let's go to the function. Another function is going to be normalization, which is going to return us the value of normal vector with normal unit vector. So we are going to give that normal vector with some magnitude. It's not going to be a unit vector, so we need to normalize it. For that we are again going to use this simple formula. I hope you guys know about this unit vector concept, right? So you can see unit vector is nothing but the vector divided by its magnitude. So we are going to use this thing here in normalization. So again it's going to be a 3D form vector, so we are going to use vector 3 normal. It's going to take a single vector 3, which we are going to take as the axis. Since this vector is going to be the axis for our rotation, that's why we are considering giving it a name and axis only here, right? So what it's going to return, before returning it, I just need to make this thing very easy. So we need first we need let me here right here, we need the magnitude of our axis, right? Axis vector. For that purpose I'm going to start using we know it's given by, let me tell you how it's given by. The magnitude is given by the sum of their axis square of the sum the axis, like this. So I'm going to use this to find the magnitude. So let's suppose okay, so let's see, float magnitude m. I'm going to consider this as m, and square root f, since we are using a float type, so we are going to use this. So it's going to take the values and just tightly give us their value. So what do I need is, I need the component of axis dot x multiplied by itself, because we need the square formula, axis dot x. Then we are going to add with axis dot y multiplied by axis dot y plus axis dot z multiplied by axis dot z. So this way we are just returning this value, that is this is going to be our magnitude. Now we need to return our value for the vector. We need to return. So this is going to be our vectoric form. So what we are going to do here is we are going to take the axis dot x, and we are going to divide that thing by magnitude. Then we are going to take axis dot y, then again going to divide it by the magnitude, and axis dot z, and then we are again going to divide this by its magnitude. Basically what we are doing here is we are returning the normal vector, right? Now this is a very basic function we just created, right? So here we are returning the normalized vector of this. What we are doing is we are just taking the each component and then dividing it by magnitude and returning that vector. So what it's doing is simply it's the same formula here, this thing just in x, y, and z form, right? So this way we completed these basic functions which we'll require while implementing the Rodrigues formula overall in our program. So let's just jump into, before implementing the Rodrigues, let's just create a 3D environment in window so that we can start working over our formula. So let's begin with this thing. So again, int main. Int main. So before int main, I need to declare a planet using our class. Let's suppose it's going to be a p, and p's x initially will be given by, let's suppose, p's initial x will be given by like let's suppose it's going to be the 2, and p dot y, let's suppose it's going to be the 0 here only, and p dot z again will be 2, and let's suppose p dot radius is again 2. So let me just put this thing also 2. So this is going to be our planet here, or the sphere, whatever you want to call. And once we did this, we need to start by declaring our very important, that is the camera here. So how we need to, because we are trying to create a 3D, since we are working over a 3D surface, so before anything we need to declare a camera here. So let's just quickly declare a camera here, because this is going to be a very important part. Before, without this it's not going to look how we want to do. So let's just camera 3D camera, which is going to be the 0 here, right? Then let's just say camera dot position. Let's set the position for a camera. This is going to be this way. We just created this camera's position where our camera is going to get set, and then we are going to set the target. So what, to which our camera is going to point. Target is nothing but the point or the vector to which our camera is going to point in a scene, right? So it's going to be the center, or the origin of our for a space, which is, that's why we are going to take 0.0f, 0.0f, comma 0.0f, right? Next we need to see how much the altitude of our camera is going to be from our plane or from our any point. So we are going to take camera dot up, and this is going to be nothing but 0.0f, comma 0.0f. I'm sorry for this, 0.0f, and then we are going to take this just 1 unit up here, then again 0.0f. So we just declared the altitude for this, and then camera's field of view we need to declare. For declaring the camera's field of view, what we need to understand here is field of view is just the angle in degrees. So how much angle you want to, or how much view you want in a single location. You can set it at any place or any way. I'm going to set it initially for about 60 degree, 60.0 f, right? So let's just set 60.0, right? So we just set the camera's field of view, and then comes the camera dot projection. So you can how camera is going to project the things, or how its perspective is going to, it can be custom, it can be first person, it can be free orbiter anyway. So let's just set it right now as perspective only. You can set it as orthographic only. These are some simple properties before setting up any 3D environment we want to start with. Alright, so we just did what we need to do. Let's begin with our init window, because for that it's all just wastage of time. So how, what is going to be our window here? It's, let's just say, 3D physics, and let's set this dimension as 800 by 800. Wait, wait. Oh, I'm sorry for this. I'm sorry for this. I wrote just comma. Let's give a title 3D physics. So we just completed making the video. Now we are going to start a while loop. Till our close window is, it's till this is false. This while loop will start, because we are just making a very basic environment here. What's wrong with this thing? Window should close. I'm sorry for this function. We just created this thing. Now I should, we created this while loop. So there are going to be the two parts, right? This is going to be our update part, and then begin drawing and begin mode 3D, and then end mode 3D, and end drawing. This is how we are going to set up our 3D environment here. So what I'm going to take here, begin 3D mode, camera, right? So we this just did what we want to do, right? While exiting this while loop, I need to close window like this and return 0 this way. So we just created an environment where we can now we can just display whatever we 3D want. So before we start, let's see, suppose I want to make a grid, right? Draw a grid 20 by 1 unit, and let's see how this looks. So here you can see we just created a grid here, uh, right? So let's see, let me show you again, like this. Right now what I can do here is I can adjust its FOV as 90 degrees, so that we can easily see how it's going to look from like this. See, now we can see a 90-degree view here, but let's say I don't want this, so I'll just keep it set to 65. It would be a better to go with this thing. So it's done. We just completed our setting up this 3D environment. Now what we are going to do here is we should start drawing our structures, right? So we already took our planet initialization, so inside the drawing I should call planet dot, sorry for this, it's p dot draw here, and Inside the update we should call planet.update here. Let's hope it works, finger crossed. Yes, you can see it's completely available here, but we can't see right now anything. So let's just initialize this by 5 and this thing also by 5. Let's just decrease its radius to 1 and 1 so we can easily see how it's looking. Right, so before we start, I need to share you some other function also called the camera update. So inside the update function, you can call it this thing also, camera dot camera update, like this. It's like update camera. I'm sorry for this. Update camera is going to take the camera, our target, and then it's going to take like this, and then it's going to take camera first person, right? So we are going to call this thing here. Now this way we can, but I think this is going to be called just after initializing our window so that it does not go like this. So there are something we need to instead. We need to also need to set the FPS of our window, and during the begin drawing mode we need to, after begin drawing mode we are going to uh, set background color. You need to layer background, and inside we are going to take, suppose, black only, right? So we just did what we need to do here. Now inside this update camera, I'm going to call this function. So we are going to call this function not outside this while loop but inside our update function. So before starting the begin drawing mode, I'm going to call this function here, call in progress, right? Let's see how does it look and work. So here, now we can clearly see how our grid is going to look here. So this is going to be our sphere, right? Before we know, we need to understand where our axis is going to be. So I'm just going to draw a simple line here so that we can see where our origin, our axis is going to be. So let's suppose draw line, right? So we are going to draw a 3D line here. What it's going to consist of? It's going to consist of, vector of starting position, which we are going to take as the origin, and it's going to be of again 3D type, and it's going to consist of vector of ending position, which is, I suppose I should go with a 2 unit only. I'm just taking the y-axis only, not the x and z-axis here. And then comes our color, so I'm going to take a red color. You guys can see here how it's going to look inside our, so you can see here inside our, this here you can see how it's going to look. Let's just increase this uh SFI. Now you guys can see how our axis is going to look here, and our sphere is going to revolve around this axis only. So As you guys can see, what we did here, we just created a very basic thing. Now, I'm just going to include something more so that we can understand how our sphere is going to use. So inside our draw sphere function, I'm going to add draw sphere wires also. So how it's going to work here is draw sphere wires, right? So how it's going to use, it's going to use again the same center, its radius, and then number of rings. So I'm going to go with 30 comma 30 slices. Color is going to be the black, and it's going to look more realistic, I suppose, like this. So you can see how it's looking here. So but the thing is, we are missing a plane here, so I'm going to draw a plane also here. So inside this, over the grid, I'm going to use a draw function for a draw plane. So we're going to use this draw plane function. Is going to tell us where our center is going to lie. So again, it's going to be vector 0 comma 0 comma 0, and then we are going to declare it's, I'm sorry, it's a 3D vector, right? We're going to declare another thing. The vector 2 is going to give us the width, and vector 2 is going to give us the width and size. So I'm going to take 20 by 2, let's say 1, and then we are going to take gray color as our plane, and you can see how it's going to look here. It's I'm sorry for that, it's just simple. So let me do some more crazy thing here. 20 by 20, I suppose. No, we just created a plane over here, and you can see how our 3D surface is going to look inside here. So it's looking like this here, a plane, this thing is passing through this grid. And let's start by initializing how we are going to create this function called the Rodrigues equation, and how we are going to implement here. So let's create a simple function through which we are going to implement here. So first of all, how the logic is going to be very simple. We are going to return a new center that is going to replace our old center inside the while loop, and that's it. And the center is going to be dependent over the angle, and inside the while loop we are going to change its angle using any speed function, so that how much speed we want while rotating. And that is going to be a very simple way, right? So let's create a vector type vector 3D form of function which is going to return as a new center at any given angle, right? So let's start with I think my caps lock is on. Vector 3 new center. Right, we just created a new center. What it's going to take is, it's going to take vector 3D center, original center is going to take, it's going to take vector normal axis, it's again going to be a 3D type, and then it's going to take the angle through which you want to rotate it, right? It's going to take the angle also. And let's begin writing this function using implementing our old concepts of our function. So you can see how we are going to implement this thing. We need to find this one, we need going to implement this one. Now since it's very complicated, since if we are going to write this thing inside our our IDE, it's going to become very complicated, like writing this in this form. So I'm going to divide these in the different form of vectors, and then we'll do this vector sum inside a C++. How we'll do this? We'll just going to understand this thing right now only. It's very easy way to do this. So, oh my god, I forgot to open this thing. Let me see where it's written here. Oh, I'm sorry for this. So here it's our notes. You guys can see this thing, right? So we need to implement this thing. Let's start by use writing this. Okay. First, we need to normalize. So I'm going to start normalizing our access vector which we are going to give here. So how we're going to normalize it using a function we created called a vector normal. Let's see, it's going to take the axis here. So let me call this axis only so that there is no confusion while doing this thing. So vector 3 n is going to be the normal function. Let's pass this thing axis here, and we just did this thing. Okay. We just normalized it. Now it's easy to implement. Before that, we are going to now the thing is, we all know there are number of scalar quantities in our formula, like this cos of angle, sine of angle, then this dot product and multiplication of 1 minus cos of angle. So we are going to write them in another way so that it becomes easy while we do write this whole thing, right? So like float rf1 is going to be, let me just quickly keep this thing. Float rf1 is going to be oh my god, so is it way like it's now it's going to be easy to implement the formula, right? Float rf1 is going to be the cos of our angle. So you can see, since we use the string library, so cos is predefined here. Cos of our angle, whatever angle we are going to give the input, and then float rf2 is going to be let's call these thing f1, f2 and f3 only. It becomes easy for this thing, f1, or you can say let's call them abc, more easy. ab it's going to be the sine of our angle, whatever angle we're going to give, and float sorry for this, float c is going to be the dot product of unit vector. So it was n here, and comma whatever the vector we are going to give, that is the center here. This dot product is going to get multiplied by 1 minus cos of our angle. You could already like cos of our angle, and this way we just completed writing this formula here. Alright, so we are done with this. Now we are going to implement these things here. So I'm going to start by writing different vectors. Vector 3a1 is going to be, vector 3a is going to be, our original vector is going to be center dot x multiplied by a, right? And then I'm going to copy this thing and paste this another 2 times. b not the b, I'm sorry for this, it's going to be a. Just going to change the components of our center, and that we just completed writing the first component here. Then vector 3 p is going to be the cross product. So we need to find the cross product here. So I think I should have written initially the cross product of our normal vector and this vector so that it becomes easy. So let's write vector CP is going to be cross of vector. We're going to multiply this unit vector we just found and with our original vector center, and we just did this thing. Now we can easily write cp dot x going to be multiplied by b comma cp dot y going to be multiplied by b comma cp dot z going to be multiplied by c. Right, we did this. Then vector 3 c is going to give us the last part. We need to multiply, like we need to find the dot product just unit vector, so we know it's going to be the n dot x multiplied multiplied by c comma and dot. Let's just copy and paste this thing only. Control plus c, control plus v, right? And just change their axis component and set. And here we did in a very professional way, not much, and we just completed writing center. Now what it's going to return is going to be the sum of this thing. So let's just return what we want to return here, and it's going to be a dot x plus b dot x plus c dot x comma a dot y plus a dot b dot y plus c dot y comma a dot z plus a comma b dot z plus c dot z. And we completed our returning our vector a new center here, and this way we completed implementing our new center. This is going to be the implementation of Rodrigues formula. Right, we just completed implementing all this formula here. So let's just now we completed this. Now we are going to return this inside our you know inside our update function. So after updating this thing, p dot center is going to equal to new center. Now it's going to be new center. We need to implement the old center. Now the axis, how we're going to give the axis. So axis is going to be our this line, this vector, this thing how we created here. It was the line 3D. It was an origin vector to this vector. So we are going to write this thing here, vector axis. So let's just give this thing, yeah, the 3 0 comma 0 comma 0 comma 5 comma 0. We just give an axis to this, and then we're going to give an angle. So inside this I'm going to declare any angle which is float angle, which is going to be initially 0 here, and I'm also going to declare a float speed which is actually going to be 0.01 initially. So we just created this, and now we are going to add an angle here which is nothing but new center. Inside this loop we just updated this thing, and we're going to get the new center. Now what I'm going to do here is I'm going to increase its speed by the speed I have already created. And let's see, is it really going to work here? And you can see here, it's working. It's rotating about this axis. But to get this thing more accurate, so as you guys can see that it was not working as we wanted. So let's look what could be the problem. So you can see in our function, I found a very pretty bad here. So you can see I was multiplying here by bb and then again I multiplied by c, which is a very bad blunder, right? So let's multiply this by b and let's save this thing and let's run it again. Now you guys can see it's running as expected. It's running about the axis as we wanted, and this way we just created this 3D render. We wanted the way we need to. We can add some other things, like we can add some more things, like we can add a planet here or anything. We can fix our camera, and this way we did what we wanted. Thanks a lot for watching this video. I hope this was my devlog, since I'm towards developing my own engine, so it was the first step for understanding 3D vectors and implementing those 3D vectors using C++ in any graphics library. I'm using Raylib here. Thank you.